I am Jesús from EURECAT. I am a technology transfer manager in the robotics group. So I'm mainly in charge of promoting the robotics technologies. So EURECAT, as some of you may already know, it's a technology center. So we are a non-profit private foundation oriented to applied research. So our main objective is to provide and add value through technology to our industrial network. We are scattered in Catalonia, so we have several centers around Catalonia. We want to be close with our partners and our industrial companies. We have over 1,000 clients accumulated over years, and most of our activity, half of it is oriented and has some SME involved. Okay. EURECAT has defined several science and technology pillars in which we would like to focus to provide value to the companies, and one of them is robotics. You can see it here. So if we now focus on the robotics group, so we are 20 researchers working on different applications. We have accumulated an experience in both in R&D projects, but also in industrial services. So you can see here some figures. If you are familiar with the European ecosystem and nomenclature that it is used, we claim to be a digital innovation hub in robotics. So that means that we not only provide technological services, but we can provide also access to public administration, to politicians, stakeholders, also to end users and different industrial associations. So we are also in contact with standardization committees, and we would like to provide an end-to-end services to companies. Thanks to this, we are also part of 3 projects, granted EU projects, that are meant to build a network of such kinds of institutions in Europe. And thanks to this, we actually have access to the knowledge and to the researchers, and we are actually in contact with similar institutions that we are, so that we can complement our offering in technology, but also in services to our local ecosystems. Okay, so we want to be really a local contact point to access the robotics in Europe. Okay, so we can do this through different services. So we go from turnkey projects, but also we enter into the very early phases when a company is thinking on how to digitize their activities. So we have also a methodology to work on technological roadmaps and proof of concepts. We also do benchmarking of new components. We try to be up to date on the technology that is on the market. When it comes to the activities and the projects we run into the robotics group, so we started very driven by the demand on the manufacturing industrial companies around us, implementing advanced applications. So we always try to complement the activities of system integrators and technology providers already in the market by adding value. So more and more we have moved to implement an endo robot with and smart behavior and more intelligence, not only in the industrial scenarios, but also into the field robotics. Then when it comes to the activity we have in drones, we have projects that involves the outdoor flight of drones, for instance, for search and rescue and environmental disaster management, also some in environmental impact assessment and in construction sector. But today I would like to focus in one specific research line we have, which is the drones for confined spaces. Okay. Within that line of research, we have several running projects and one finished project. And today I would like to mainly share with you a video. Okay, I'm gonna use that video to illustrate my speech. So I will be stopping the video in case it just not runs smoothly. Okay, so let me know if it's not working, and I can manage differently. So that project, the aim of that project is to develop a drone that can operate for inspection tasks in a sewage network a big city. Okay, that project was performed and was executed in cooperation with FCC and also some small companies in Catalonia. A city like Barcelona have more than 1,000 kilometers of subterranean galleries as part of the sewage networks. They are inspected daily through a brigade composed by 4 operators that need to take very specific measures to not put them in risk, because that's a very unhealthy environment and workspace. Okay, so that was the idea was to provide a tool to this brigade so that this inspection can be run into a different way and reducing the exposure of these brigades into these hazardous environments. Okay. Barcelona is spending more or less 1 million per year into this kind of tasks. Okay, so at the end of the project, we calculated and we estimated that by providing this tool, we can reduce this expenditure by 30%, which means reducing expenditure or keeping the same expenditure, increasing the quality of the inspection, because you could actually run more inspections. Okay, so FCC provided the domain knowledge and also a very good resources, so we could actually get GIS data, so a very specific, very well documented digitized map of the sewer network of Barcelona. So we used this to actually plan the routes, the inspection routes of the drones, and make an inspection plan, daily inspection plan to keep productivity. Through this map, we know the cross section of every segment of the sewer network. So thanks to this, we know beforehand which is the environment that we are going to face. So in that project, it was very important to implement an easy deployment of the overall tool plus interface, so that the brigades can actually use them. Okay. So during the whole project, we had close contact with the brigades, and the brigades were inspecting and supervising the field campaigns that we were actually performing. So we did a very exigent, very difficult scenario in order with respect to regarding aerodynamics. So in these videos, you can see how unstable can be the flight of a drone. So we had several iterations until we get a sufficiently stable drone frame and drone configuration to provide this application. Actually, we have not found a similar product or project that has been run in same conditions. So think that we are flying 60 centimeters width drone into a section which is 80 centimeters width and 1 meter, 1.2 meters of 8. So we currently have some projects running in which this section is much bigger and the flight is much smoother. Okay, so we kind of started the house from the roof, I would say. So the differentiation with respect of other products that you can see that can fly in this kind of scenarios is that this drone is endowing autonomous capabilities, so that it can recover from a faulty flight. When it loses communications, for instance, it can reverse flight and be back to the origin. Okay. In order to relax the piloting skills of the operators, because we didn't want that they should actually go through a certification process for piloting the drone, we implemented a user interface which is very intuitive, and actually it's a unique soft manipulation. It's a soft command of the drone. So you basically indicate whether you can go forward or backward, then up and down, because there is actually not much space to move laterally. And you can see here how it looks like. It has different menus you can choose. In this one, you can see and you may recognize some parameters that are useful at research level to track whether the position of the drone is in line with the path plan. Okay. So the drone has some HD camera so that the operators can actually see what it's seeing the drone every time. Okay. I would like also to stop a bit here because one of the added value of these projects is that we implemented a platform for data analytics so that at the end the operators do not have to go through the whole video, because at the end, if an operator should go and see and play the whole video of the inspection, let's say offline after the flight, we would not be saving any time. And also the processing capabilities of a drone on the fly with such characteristics are very limited. So the processing were mostly happening after the flight. So we developed and trained a platform in that case to recognize some defects with deep learning. So here the platform is recognizing some texture in the walls of the seaware. So we did this with the FCC. We trained that platform, and the data analytics software could recognize this. So this is also the second very interesting data analytics functionality that we implemented. We are doing some structural assessment of the overall cross section and of the seaware network, since we know that the cross section that we are actually flying on, so we could compare the 3D reconstruction that you can see on the left with the theoretical measurement of that profile, and basically by comparing distances and also by recognizing holes in the wall and objects in the 3D reconstruction, we could pinpoint defects, but also structural elements such as manholes or inlets. So this is useful and interesting for FCC and for the public administrations to have an inventory of the seaware network up to date, digitized, that they can exploit. So here you can see, for instance, that in that case we could detect how this infrastructure just collapsed. That was a section that was not accessible by humans, and it was actually dangerous to allow the access of humans because of this collapse event. So they didn't know what happened, so we could run the drone and then detect this mismatch between the theoretical profile and the actual situation. And just to finish, some more details on the platform that we developed. So the operators could actually run the whole inspection routine offline. And if you can see in the bottom line, you have a timeline where several elements are indicated. So in blue, they could see structural elements, and in yellow and red, they could see some defects. So, and at the end, and to finish, and also to explore different interfaces that we could use in the future for the operators to have more, have a better immersive experience, because at the end, yes.
Just, we are already running a bit over time, so 1 more minute, okay?
Yeah, I'm done with that. So basically, we implemented this platform and all the information in that platform into an augmented reality interface, so that operators could have a more immersive experience. Okay, and actually, with that, I am done. So sorry for the delay, but this is it. So yeah, thank you very much. I'm happy to answer any questions.